This is chapter number 6, which is data types revisited. So we have seen about the primitive data types, char, int and float, but there are other options which are available regarding this char, int and float depending upon the requirement. So not only the primary or primitive data type, along with this you can have a character, say unsigned char, signed char. You can have an integer which is called as short int and long int. So what this short, long, unsigned, signed means. So let us discuss in this chapter what this character, integer and float have to offer you. Integers, long and short. Integer, we are talking about integer in C, so we need to understand that it is compiler dependent. For example, if it is a 16-bit compiler like the Turbo C or Turbo C++, the range of integer is negative and positive. These are the numbers. Why? Because integers take negative as well as positive number. So if you take 16, 2 to the power 16 to be exact, you get, if you combine these two, you get this number. Since if this is a number line, then you take 3, 2, 7, 6, 7. Here this side you have minus 3, 2, 7, 6, 8. So this is the range. Similarly for 32-bit compiler, it is 2 to the power 32 and just divide it into two parts, left, right. And I'll tell you why this number is 1 greater than this one. It's in the negative, but it is 1 greater. We'll talk about that later in the discussion. So whenever we are dealing with, say, 16-bit, this microprocessor like this Intel, so this C program, when it generates machine language code, this is targeted toward working on a 16-bit microprocessor. As we said, 8086, 8088. But if you are making program in VC++, so the 32-bit compiler, this generates a machine code which is targeted towards 32-bit compiler like the Intel Pentium. So this means that a 16-bit will work on 32-bit, 32-bit on 64-bit, but the backward compatibility is not there. Means if you have made a 32-bit program, it's highly unlikely that it is going to run on 16-bit. Just remember that out of this 2, or you can say 2 for 16-bit, 4 for the 32-bit, this is the byte which this integer take in the memory. So out of this 2 or 4 bytes, this is used to store an integer. The highest bit is used to store the sign of the integer. Highest bit is for the sign. So if you have a negative number, that means the highest bit will be 1, and if the number is positive, the higher bit will be 0. Highest bit will be 0. So there are various offerings like short and long, and the thing is that sometimes you don't want the integer is there, but you don't want that long that integer. You have the numbers. You know that in your program the numbers are going to come less, but there are possibility that you are not satisfied with integer. You want more than integer. Then you have to go for a long. So short, usually in our discussion when we are dealing with the Turbo C and Turbo C++ compiler, this short takes 2 bytes and long takes 4 bytes. So short, and this totally depends on the operating system and hardware also. So let us give a least limit for that. Shorts are at least 2 bytes big, means short cannot be less than 2 bytes. Long are at least 4 byte big. That means if a long integer is being defined or declared, it is going to take at least 4 bytes in the memory. Shorts can never be bigger than integers, and integers can never be bigger than long. So if we have short, then we have integer, then we have long. So this is how it increases, the size increases. So this is the summarization. If you are dealing with 16-bit compiler, the short will be 2 byte, integer will be 2 byte, but the long will be 4 byte. If you are dealing with 32-bit compiler, short will be 2 byte, integer will be 4 byte, and long will be 4 byte. So how to declare them? Just put a long in front of that int I. Int I you have been doing a lot up till now. Just put a long here. So this long int ABC or long int I means now this long integer is taking a bigger size. So it is going to, for this example, if you take this, it is going to this I in memory wherever it is stored. If I is stored, say I has some value 3. So it is going to be stored, and this is going to take 4 bytes. How much memory? 4 bytes. But please understand, if the size is higher, the program will be bit slower. Because if you see, this is 4 bytes. So 4 byte means 4 into 8 bit. That is 32 bit. So the range goes from 2 to the power 32. This is the range. Means you take half of this on the negative side, half of this on the right side. This is how it goes. So if there are such things like things as longs, you should have something which require shorter than what is required. So this integer that needs less space in memory, which is short. So this is just to speed up, increase your execution time. So how to declare a short integer? Just put a short in front of int, short in front of it. And one more thing, short int and short, they are similar. So even if you write short int or short, they are equivalent. Even if you write long int or long, they are equivalent. So you don't need to put an int here. You can do this shorthand. And most of the C programmer, they prefer this kind of declaration in their program. Now, sometimes we may have certain situation where the constant is small enough to be an integer, but still we want a larger space. That means we want to give it much large as a long. So we are talking about constant here. Please understand, we are talking about constant. So whenever we are talking about a constant, we have to put a capital L or a small l at the end of the constant to make it like this. If this is 23 number, so you have to put a L to tell the compiler that this is a constant which is long. Integers, signed and unsigned. You know that integers are capable of handling negative as well as positive values, positive numbers which are not decimals. So when we declare something as unsigned int num students, we know that number of students can never be negative. Can you assume that your students are minus 16? That is not possible. So unsigned, you are actually doing or shifting the range. That means this is 0, this is minus 32768, and here you have 32767, which is plus. So you don't want this area. So you are saying that I don't want signed value. So you are putting unsigned. So you are taking this range and adding it up here. So how much it becomes? 32767 or 32767 plus 327, this 8. Just add 32767 and 32768. You will get 65535. So this is the range you get from 0 to 65535. So you are just, if you declare an unsigned, you are increasing your range. So declaring an integer as unsigned will double the size of the largest possible otherwise. Unsigned, now when we do this on declaring the integer as unsigned, you are freeing the leftmost bit. We know that leftmost bit is what? It is the sign value. It gives you sign, but you know that the unsigned means this is always positive. So you are freeing up that value. You don't want anything to be, or one bit to be wasted for plus. Why? Because now the leftmost bit is free, and now it can be used to store the sign of the number. Okay. So note that this unsigned integer will still occupy 2 bytes only. Only the positive range has increased. So how to declare unsigned integer? Unsigned int I, unsigned I. This is to be seen. You don't need to put int. This is the shorthand form. Like the unsigned integer, you have short unsigned integer, you have long unsigned integer. So by default, this short integer is a signed short integer. If by default the long integer is signed long integer, if you want to make it unsigned, you have to specifically write this unsigned. You have to specifically give, otherwise it will be signed. Char, sign and unsigned. This character is taking 1 byte. Now this character is essentially an integer only. So parallel to the signed and unsigned integer, like the short and long, we can have unsigned and signed chars also. Char take 1 byte, but it can have different ranges. I'll tell you how. How to write a character, or how to declare a character or define a character. Char ch equal to a. So now this a is having a value which is 65, which is in binary. So this is all good. And if this 65 binary can be stored, you want to store minus 54 also. This can also be stored. And this is now a signed character. This is now a signed character. So a signed character simply means because a signed character is simply 1 byte. So it goes from 0 to 127. And here it goes from 0 to minus 128. So these are the highest and lowest limit. When you take an unsigned character, this side goes here, and now this is added. So this will be 127 plus 128. So you get 255. So the range is from 0 to 255. So let us see a program now. This ch character is till 291, or the value is 291. You want to print out the value of this 291 along with this character equivalent. We know that for ASCII, if we are dealing with ASCII, we have only value till 255, 0 to 255. 291 is above our range. So this program, what you are going to expect? Possibly 291 and the character which is related to 291, but this is not going to show. Why? Because the ch has been defined character and the ranges are from minus 128 to 127, and 291 falls quite ahead of 127, which is not in the range. So CH will exceed the range. So whenever you exceed the range in any of the data type, if you exceed the range, when it surpasses the 127, it comes 128, then it will not give you error. But in fact, this 128 will go here. So minus 128 will be shown. Okay. Now this 127, it goes from 0 to 127, then it comes back to 128. Then again 128, it will search for 128. And then you see that still it is not complete because 255. Now you see that this 291 minus 255, 291 minus 255, or you say 256, say, because total number is 256. So this 11 minus 6 is 5, and this you have 8 minus 5 is 3. So you need to go ahead of 0 till 35. So that is how 35 will come up, and the character which is corresponding to this 35, which is the hash, will be shown. So in this program, you will see 35 and hash. Why? I just explained you. We have another program that will make the concept clear. See, you start with 0, you go up to 255, and you are adding it up, character CH++. Now this is simply showing that from 0, this will show what? First of all, the number, so 0, corresponding character, then 1 corresponding character till 255. This is obvious from this program. All the characters will be shown. But again, this program will not show you this as expected. But in fact, this is an indefinite loop. Why? Because the character is assigned as simple character. It is not unsigned character. So the highest range is 127. Highest range is 127. And as we have just known, that when we go or when we surpass this 127, it will not go to 128 because 128 is not available. Rather, it will go to the other side, minus 128. It will go to that side, and now this again comes here till the time this CH++ is going on. But as it reaches 128, again 128 is not there. So it will go on, and this loop will be indefinite. I hope you got the idea, because it goes from 0 to minus 127, with this 0 to 127. Then it again go back to minus 128, means here. Then it again decrements because CH++ means it will increment the value. So here it will decrement the value. Plus means negative will, if you add 1, it will go here. So again it will come here, and this as you go ahead, it will go again and again. So this will actually dangle, or you can say the oscillate between these two values. So you'll not be able to see anything, right? So how to overcome this difficulty? We have unsigned character for this. The same program, if you write unsigned character and you just put this as 254, not 255, because once this is 0 to 255. The range is 0 to 255. That means if you are starting from the total value available to you is 256. So when you are starting with 0, you only go up to 255. So if you check 255, you are already ahead of 1. So 256 will be next value, and that is not acceptable. So you have to stop at 255. For that, you have to just check for 254. You have to go up to 255. That is why we have changed this to be unsigned character. Now, unsigned character is having a range from 0 to 255. You are trying to go up to 255 and putting the values and printing the values. Now everything will be fine. All the characters from 0 to 255 and the numbers will be shown. Floats and double. Float occupies 4 bytes. 4 bytes means 4 into 8. One byte contains 8 bits. So there will be 32 bits. So 2 to the power 32 is the range. You can say you just divide it into 2 parts, because again the float and double, they also take the negative value. So the range is this. And if you want higher value, double can be there. Double is taking 8 byte. So 8 byte means 8 into 8. So this will be 2 to the power 64 possibly. Again, you divide into the range, negative and positive. These are the values. How to declare a double? Just place a double and put the variables. Now, if you want more than that, sometimes 8 byte is also not enough. For that, we have long double. Long double takes 8 plus 2, that is 10 bytes. 10 bytes means 2 to the power 10 into 8, that is 2 to the power 80. This is the range. 0 to 280. This is for unsigned, and if you want the signed one, just divide it into half, take it here. So this is the negative and positive range for long double. So this is how this character int, float, doubles can be used. And now let us write a program to know what exactly is going on and how to print them. See, the format specifier, they are also different for all these. Take char C. When you want to print a character C, you want to enter the C and D first of all. C and D, and you want to print C and D, it will be printed. It will be simply %C because these are character. %C. Now let us come to integer now. We'll go to float from here. Integer. You are scanning the value I and J. You are taking the value. But whenever you are taking the value of J, this is unsigned integer. So you have to take it in %U, right? And whenever you are printing also J, you have to print it in %U. This is unsigned. Now let us come to this short one. Again, you are going to take K and L. So this K and L will be taken, but this L is unsigned short. So you have to take it in %U. The K will remain like %D. In long int, this to long int, again, this long int has to be taken as this because this is long int. So it will be LD. And this is the unsigned long int. So it will be LU. LD and LU will take. When you come to double and float, long double, float we have already taken. Float has nothing to worry about because X will be taken in %F. We have known about that. When we are dealing with double, it will be LF, and when we have long double, we have capital L and F. This is small LF, this is capital L and F. Okay, so F remains small. So let me summarize what we have learned up till now. This signed character, unsigned character. Unsigned means there will be no negative, but the bytes will be same for the character type. You use %C only. In short, signed and unsigned, the range is for 2 byte is this, and there will be no negative for short unsigned integer, again 2 byte. But for unsigned, you have to take %U. When we come to signed and unsigned integer, again the things remain same here for 16-bit compiler. We are only talking about 16-bit compiler here, and you can just think about 32. It will just increase as I just suggested you. So this will be 2 byte. This will be %D and %U. Long signed long int means LD you have to use, LU you have to use, and this will take 4 byte in 16-bit compiler. This is the range, and just add these two, you'll get this range. Now float, %F, double, small LF, long double, capital L and small f. This float 4 byte, double 8 byte, and long double 10 byte. There are things apart from this, that as we just saw, that the size of the integer is compiler dependent. And this is true with character and float also. So it depends on the microprocessor for which the compiler targets its codes. The accuracy of floating point calculation may change. Just take an example of 22.0 by 7.0. So this will report more accurately by the VC++ compiler rather than the TC++ compiler. Why? Because TC++ is compiled for 16-bit 8086 or 8088 microprocessor. And this microprocessor, they do not offer any floating point support, but the TC++, they perform all floating point operation. They have a special software piece which is known as the floating point emulator. So this emulator has limitation, and hence they produce some less accurate result. So this emulator becomes a part of exe. Then now when something becomes a part of exe, it will increase the size of exe. And if you have an increased size, there will be a performance penalty because bigger code will take more time to execute. So you see, if we look at the range of the character integer, and you see that there is a number extra in the negative side. How? See, if you take character, here you take 0 to 127, and here you have minus 128. So one number is higher. Why? Because the negative numbers, they are stored not normally, but they are stored as 2's complement of its binary. So if you, let us see minus 128. So what is the binary of 128? Let us not take minus now. 128 is simply this one. Let us take the 1's complement, which is the simply making 1 to 0 and 0 to 1. So this will be the 1's complement. Now 1's complement is added, for 2's complement, 1's complement is added with 1. So we add 1 to this. We just add 1 to this. So the 2's complement will be this. So this gets stored. So a 2's complement is obtained by adding 1's complement to 1 complement. 1 complement is simply changing 0 to 1, 1 to 0. So minus 128, this gets stored. So this is a 8-bit number. And this can be easily accommodated because this is 8-bit number in character. But when you have plus 128, this cannot be stored in character because the binary equivalent of 127 will be, these are, all 8 values, and then this is plus. So you have 0 here. So the leftmost 0 is a positive sign. So this becomes a 9-bit number. Therefore, the 1 plus 127 can be stored. Why? Because this is plus and 127 is simply like this. This can be stored in binary. And this turns out to be a 8-bit number. And what we have already seen in the program, what happens if you attempt to store 128. We know that 128 is not there, only 127 up till we go. So it takes the negative side. It goes to minus 128. And this is why, because from 9-bit binary of this plus 128, which is this one, only the rightmost bit rightmost 8 bits get stored. So when this part is stored, the leftmost bit is 1 and it is treated as a signed bit. So the value of the number becomes minus 128, since it is indeed the binary of minus 128, and this can be understood by the previous discussion. So you can verify that if you want to attempt 128, you will actually go to minus 127. 120, because 127 we have range, 128 you go to minus 128, and 129 you go to minus 127. So we exceed the range from positive side, we end up on the negative side. And this is true for negative side also. If we exceed the negative side, we go to the positive side. Storage classes in C. We have already seen about the type, data type. So every variable apart from this type, it also has a storage class. So what is a storage class? We'll see about that. And this totally depends on where to store. This is the type, how much memory it is going to take in the actual placement. But storage class means where to put. And here we assume the storage class depending on the context, because the way we are going to use the variable, we are going to put it in some storage class. We have already been using these storage classes unknowingly, but today we'll talk about exactly that, precisely telling where you are putting unknowingly, and now we'll learn about how to knowingly place it somewhere so that our program can run according to the way we want. So there are various places where we can keep the variables, or the locations are there, memory and CPU register. So these are the two locations. So the variable storage class will tell us where the variable is going to be stored. This is important. Storage class means where the variable is going to be stored. What will be the initial value of the variable? Means storage class will define what will be the initial value if you have not specifically given the initial value. What is the scope of the variable? This. And what is the life of the variable? Scope and life we will see. Scope means in which functions this variable will be available, and life means how long the variable would exist. So there are 4 storage classes: automatic storage class, register storage class, static storage class, and external storage class. External storage class. What is automatic storage class? As I just told you that we were using this storage class and we were not aware that we were actually dealing with the automatic storage class. So the features are: the storage is in memory. First of all, the variable will be stored in memory. There is no initial value. If you don't provide it, it will be unpredictable. The scope is only limited to the block where this is defined or declared, and the life will again be inside this loop, or you can say block, not loop, but inside the block. So let us see a program. This is int ij. We have not put up till now auto, but there is auto always. This is a default. Int ij. Now the output can be anything because we have not initialized ing, and because it is auto, it is unpredictable. So it may take any garbage value. Garbage value is that value which is not not of our purpose. The scope and life will be seen here if we have declared and defined a variable I, which is auto. Now we have one block, second block, and third block. So when you take I outside, this is known for this whole block, and these 3 blocks, 1, 2, 3, they are all inside this block. So I will be known here itself, and this place also. So 1, 1, 1 will be printed. So we have seen that the scope is outside, means you have made it for the main block. That is why it is seen in all the points. Let me tell you one more example of this. If now I is 1, this is auto. This is not automatic. Please understand, it is not automatic. It is just auto. This is auto, int I equal to 2, and this is int I equal to 3 auto. Now this 3 is known inside this block. So for this, I3 will be printed. This is I equal to 2. So this is known inside this block. So here 2 will be printed. This I is known inside this block, and this printf is inside this block. So this will be 1. So what will be printed? 3, 2, 1. I hope you got the idea that because of the block, because the life and scope is inside the block of auto. Then we have register storage class. CPU has certain register which it uses for various computation purposes. Now CPU register, if you take the place of CPU register, the storage will be CPU register. Default value is nothing, so it will give you a garbage value if you don't initialize it. The location is again the block, only the block, and the life is also till the block. Similar, these two are similar as we have seen the automatic storage class. So why we want to place something in the register? Because CPU will give you one register, you will place it in the register. But if at all that register is not free, then it will be treated as automatic only. It will be treated as Automatic only. So if you specifically say int I equal to register, that means you are using this counter 10 times. So why not to take this, because we are using it again and again. I is number of times. So put it in the register. So this will be kept in the CPU register. And as I said, if CPU is busy, it is not in the position to honor this register, so it will be auto. It will be auto by itself. The microprocessor say, not every type of variable can be stored in CPU register, because if the microprocessor is 16-bit register, so they cannot hold this float and double. Why? Because this is 4 byte and 8 byte respectively. So if you use the register storage class for a float and double variable, you won't get any error message. You will not get any error message. The only thing which will happen is this will be treated only as a auto storage class. Static storage class, very important. Static storage class, the storage is memory, and the important thing is the initial value is 0, and the scope is also very important. The scope is local to the block in which the variable is defined, but the most important is the life. The static variable will be known between different function calls. So if you want a value to persist between different function calls, then you have to make it as a storage class, which is called as static. So let us see the same program with automatic storage, and what I said about automatic is it is an automatic, but we don't write automatic here. We only write auto. So this is automatic and static. See, we have a function increment. Now this I is declared and defined inside this increment function. When you print I for this function call will go, I will be printed and I is 1. Okay, 1 will be printed. Now I has been incremented. Now I equal to I plus 1 means again this will be called, but it will again initialize because it is automatic variable. This again will be initialized to 1, so you'll see again 1. Similarly for the third time also, because again it is initialized, it will be 1. But the static class is not like that. If you put it in static, then between the function call also the value will remain the latest one. That is, in this first call, static int I equal to 1, so 1 will be printed. Then I is incremented, so it becomes 2. So when the second function call will come, this value has become 2, so 2 will be printed. Now I equal to I plus 1, so 2 plus 1 is 3. Again this function call will be made, and now this will be 3. I hope you got the idea. So this is how the static is different from auto. Static will keep the value between function calls also. Let us take one more program. This is a pointer variable. This is a function, and we have a pointer here also. Now this function fun is called, and when we set this star j to this function, k is 35, and now ampersand k, we are trying to print the address of k, and that will be taken in j, which is actually returning address, and this will be printed. Okay, what you assume it to be? What do you assume it to be? When we are returning an address of k to this function and collecting it in j, so j becomes actually the pointer of k, nothing but the pointer of k. So 35 will, wherever it will be, the address of 35 has to be printed, right? So this correctly prints 35. Now just call any function immediately after the function call, this function call. This will give you a garbage value. I'm saying you print here, it is okay, but if you print it here, it will be a garbage value. Why? Because between the function calls, because this is auto, this value will not be controlled. Now we want that to be seen. We want that value with the address has to be printed. That means we cannot use the auto. We have to use the static, because we are dealing with function calls here, and we want the value to remain or to persist even between the function calls. External storage class. The features of variable of storage class are like this. Storage will be memory. Again, the initial value will be 0. This will be 0. The scope is global. This is very important. The scope is for the program also, for the functions in the program, along with the other programs also. So the life is as long as the program execution doesn't come to an end. So this external variable, because they are global, the scope is global, they are not local. So they are declared outside the function. They are declared outside the functions. So this is how it is being done. This is main function. We have declared it outside. This int is outside. So we have I. Now even if you call this increment I equal to I plus 1, what will be the value? This I is initial value, because let us take it as, say, I equal to say 0. Okay, because I equal to 0, how? We will not take it. This is an external variable. External variable will do it by itself. It will initialize I to 0. So I will be 0. Increment means I equal to I plus 1. So 1 will be shown. Then again increment is called. So 1 will become 2, because this value will be just like static. Then decrement. So now this decrement will take 2 as a value. So 2 minus 1 is 1. 1 will be printed, and then again next decrement, 1 will be decremented, so it will be 0. So 1, 2 and 1, 0 will be printed. Because this will be initialized to 0, it will be remain like a static variable. That is how you have between function call also you can use this value. So this is how it goes. Now see, int x equal to 21 here, and this int y is equal to 31. This x is here, but since this is given after this main, when the compiler actually transfer control, first it will go here, then here, and then it will encounter y. But why, if it is not given extern int y, if this line is not given, it will give an error. Why? Because int y equal to 31 is declared outside and after the main function. So you have to say extern in y. That is why extern in y, if you put it like this, int y equal to 31, that will be also good. That is why for this int x equal to 21, it will automatically take the value. You don't have to put any extern int x. But if it is not there, you have to specifically say it is extern. There is one more thing you must realize here is always the internal or the local scope. This local scope is always given the preference. How? If x is equal to 20 and you want to print x here, 20 will be printed. When you come outside, this is outside the scope, you want to print x, then 10 will be printed, not 20. This will be taking preference. So 20, there is the conflict here is we have x as 20 and x is equal to 20. So this conflict will be resolved inside this function by taking this value, the local variable. And because there is no conflict, x is defined already 10, so 10 will be printed. This is how it is done. So which to use when? Which storage class you would like to use when? There are various things which Dennis Ritchie has told about this. What are the position? Because whenever you are doing programming, you need to economize the economy is very important. So you need to economize the memory space consumed by the variable, and then for the speed of execution also program, you need some good storage classes to be kept. So the rules are the static storage only if you want the value of the variable to persist between different function calls. Otherwise, this static will always remain, and that will keep the memory by itself. Register only when you use a variable counter again and again in your program. If you are using a variable heavily, then you must keep it in register, otherwise not, like the loop counters. Then the extern. Extern means you want to take the value as static, you want to initialize, between the function calls also you want to use, and after that you want them to be known for the different programs also. For that you use extern. Auto is always good. It keeps in memory. Its block is its life and scope is only between the block. So we generally use this auto storage class. So let us summarize. We can use different variations of primary data types: signed, unsigned, long, short, float, double, long, double. So they have different format specification to print in the scanf and printf. The maximum value of a variable that can hold depends upon the number of bytes it occupies in a memory. By default, all the variables are signed. You have to specifically give unsigned if you want to increase the range. We can use various storage classes like auto, register, static, extern, and they all are governed by the 4 properties: storage, default initial value, scope, and life. So this is all about this chapter. Thank you so much. Take care of yourself.